Okay, I did number 2 in class, so I'm going to go ahead and do number 3 because it's probably one of the harder ones as well. And the first thing you want to recognize is this is a round down function, which I told you would have the closed circle to the left and the open to the right. Remember, we said it's kind of like you're heavy on the left, you're rounding to the left or rounding down. And then when I look at this, I recognize that I need to do some work inside of here. And if I think about factoring out a 1/2, so I'll show you kind of what that does, and that would leave me with x plus 2 and then minus 4. So then you can see your translation point is -2, -4. And remember, with all these, you go straight to -2, -4, and you bubble in your first point. And because this is a rounding down, we're going to go to the right with our open hole here. So there is a stretching going on here. So this 1/2 is going to be a horizontal stretch by a factor of 2. And then what you have to recognize when you do that is it's basically just making your step longer. So I'll go to the right like this. So that's the first step. And then the -1 out front is saying instead of going up to the right, I'm going to go up to the left. But I'm only stepping by ones because there's a 1 here. So that means I go up 1 on the left side this time to put my next open hole. But I do still stretch it by 2 to continue that pattern. So up 1, stretch by 2, and then that's as far as I can go there. I can do this as well over here. So closed hole, open hole, closed hole, open hole. Now, so you notice that these are stepping by ones for our y's. So that kind of helps us. Our y values are all integers. So our range is all integers, and of course our domain is all real values. You could also write that -infinity to infinity like that. Okay, so that's what that looks like, and I think that should get you going for those types of problems. I will just quickly remind you on number 4, this is a rounding up or a ceiling function because it has the little line at the top. This is translated -5, -6. So I would go to -5, -6, and I would put my closed circle in place. And then because it's rounding to the right, it's going to be heavy on the right. It's rounding up. So what I'm going to do is I'm just going to simply put my open hole here. I'm going to jump by 3's here. It is going up to the right. So, sorry, that should be an open hole. Just be careful that each function, no matter which one, rounding down or rounding up, the vertical line will have one closed and one open circle. So just make sure you know that. But that gets you started on that one. And in this bottom section, I want to remind you, rounding down is just when, if it's 2.2, you round down to 2. -3.4, this one is rounding up. So if you think about the number line, -3, -4, -3.4 is somewhere in here, and it doesn't matter exactly where, it's just between -3 and -4. So when I round up, I round to the right. So I'm rounding to this -3. This is a rounding down, so I'm going to round to a -1. Let me show you what that would look like. So 0, -1, this is where my value is, -0.01, so it's really close to 0. Rounding down means round to -1. But that should get you started on those. And on the next page, I'll just do a couple of these. Essentially what you're doing in this whole section, 1 through 8 here, you're looking for the x and its domain. So for example, if I'm looking for a 10, I'll just jump to this number 4, 5, and 6. I'm looking for a 10 in my domain. So I have to come up here and I have to see which one of these domains contains a 10. And it's actually this third one right here. 10 is greater than or equal to 3, so I know it's going to fit here. And what I'm going to do is I'm going to take my function, x, which is 6 minus 2x, and I'm going to plug in this 10 to the appropriate function. And that's just going to be 6 minus 20, which is going to be a -14. So that's how you would do that. And the next one is f of 2. So I have to see where is 2 in each of these domains. Is it in this first one? No. 2 is not less than or equal to 1, but 2 is between 1 and 3. So this is the function that I need. This seems weird, but this is just a horizontal line. So no matter what x you plug in between 1 and 3, they all give you a y of 3. So that's how you do that one. There's not really anything to plug in, it's just a horizontal line. So that's that entire section there. The one I'll do down here is I want to either evaluate -2, 0, 2, or 6. I'm going to do all of them eventually, but I'm going to pick 2. I want to look at 2. And the reason is this kind of presents a challenging situation here. I know it falls into this domain because 2 is equal, obviously, to 2 right here. And I'm going to plug in a 2, but be very careful that you square just the 2, which is a 4, and then the negative kind of just comes along. So your answer is -4. It is different than if you had evaluated, say, a -2 as your x that's being squared. That would turn positive. So just be careful with that concept. So I wanted to go over that with you. Now, this next little section, I feel like I do need to review it with you. And I told you, I think we did A together in class. It doesn't really matter which one I do, but let's go ahead and do B here. And the first thing you want to do is just rewrite the slope as both a positive and a -1. You know, 1/2 of your line will have a negative slope and 1/2 will have a positive slope. So I'm just going to say negative and then x plus 3 minus 2, and then I need a positive 1 as well. Of course, I'm not going to write anything. It's just implied that there's a positive 1 there. X plus 3 minus 2. The only thing I really have to do is figure out which domain goes with which slope. So this opens down. The reason that's important is because it's saying that the left half of the graph is going to have a positive slope, up and then down. So the right half of the graph has a negative slope. The vertex is -3, -2. So what I'm going to do is say all x's less than -3 are going to belong with the positive slope. So this is going to be all x's less than -3, and then the other half would be greater than -3. And remember, I can put the underline either one of these locations. And that is all you have to do for those problems. You could distribute the negative, so you get a -x minus 3, and then you'd also have this minus 2 to combine. So you could rewrite it if you wanted to. The first one would be -x minus 3, and that comes from distributing, minus 2. So if you wanted to rewrite it in slope-intercept form, it would look like that. Okay, so if the key says that, that's where that came from. All right, so let's move on to the next section. And of course, pause anytime you want to work through some of these. So 13 and 14 are kind of the opposite of what we just did. And I did 13 in class. Let's go ahead and do 14 here. So you can see that you have a slope of 1/2, you have a slope of -1/2. And you know that the x from the vertex is 4, because that's where you change your slopes, at 4. So all I'm going to do is plug a 4 in right here for x. So it's going to be 1/2 of 4, which is 2, plus 5 is going to give me 7. So the y is 7. So writing this as an absolute value equation, I can go ahead and say x minus 4 plus 7. The part I don't know is whether I need a positive 1/2 or a negative 1/2. So then I have to kind of sketch it, okay? And it's really just a really crude sketch. So I'm going to be at 4, 7 up here. And then I know that for the greater than sign, meaning it's over here to the right part of the graph has a positive slope. So it's going up. And the left half has a negative slope. So this is going to actually be a positive 1/2 because it's opening upward. And it's all about which direction your equation's going, your graph is going. This is opening up, so it's a positive 1/2. If it had been opening down, then this would be a negative 1/2. So let's just review. The right half of the graph has the positive slope, so that's what I did here, positive. The left half, this is kind of like the left half, has a negative slope. So I want to go down and then back up. So that's how you would do that. All right, so let's see what we have on the last page. This is when we have to start graphing and piecing everything together. So let me just pick one of these. Let me pick number 17. Looks kind of challenging there. And I see that my domain is x less than -3. So let me put a -3 here. And then I also have one from -3 to 0. So I have another little piece here. And then everything to the right. So I have 1, 2, 3 little sections to my graph, and they go with 1, 2, 3, the functions up here, because I did them in order. Okay, now this is an absolute value, and it's been translated to -5, +4. So I'm going to go to where -5, +4 is, put a hole there, and then I'll decide if I have to bubble it in. I'm not going to bubble it in because that is not, oh, I'm so sorry. I do need to go to that point, but it's not on my line. So I'm going to start with the point there. So -5, +4. My slope is a 1. So I'm just going to kind of go up and over, putting little points in place. And then I land on the line that I need to start my graph. So my graph is going to start at -3, and it's going to go to the left. So I'm going to continue this little pattern here, and it goes up, 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 really to the left and to the right, and then it goes here and stops. So that's the first graph there. So this is graph 1. Okay, now graph 2 is a quadratic, and it has been shifted to -2, +2. So -2, +2, put a little point in place. And I know this is actually going to be in my graph because it's in this second section here, this second section. And I know that it has a 1 out front, meaning it's just the normal moves. So I'd go 1 to the right, 1 up, 2 to the right would be 4 up. So I'd land right here, and I'm going to put a bubble, and it is not underlined, so I'm going to leave it open. Same thing over here, but when I go 1 to the left, I go 1 up, put a bubble, but do you see it is underlined? So I'm going to fill this in, and it's going to be a little curve like this. So that's the second part of it. The third part of it is a line that intersects at 6, a y of 6. So 1, 2, 3, 4, 5, 6 happens to land here, and it is underlined. So I'm gonna go and bubble that in because it's underlined. And then I'm going to use my -1 slope, meaning down 1 to the right 1, down 1 to the right 1. So it's going to look like this, and so on. And then you have to continue like this. Okay, and it has an intersection, and it lands nice and neat right there. So that would be your only x-intercept for the whole graph. Your y-intercept would be here at 0, 6, and that's how you do a problem like that. Okay, now the back page. The back page is a little bit different. This one you can graph. I feel confident you can go the opposite way. That's a little bit easier. And then, but you know what, I might as well go ahead and do it for you. So the first piece of the graph is going to be less than 0. So it's going to be here. And then, so it's going to be everything less than or equal to 0. This is translated to 0, -1. So I'm going to put that in place, 0, -1, and it's underlined, so I'm going to bubble it in. And then it's just a quadratic, so it's just going to kind of be the left half of the quadratic. So 1 to the left, 1 up, 2 to the left would be 4 up. So then this is this sketch right there. Then the next one is a line, crosses at -1 right here at the same point, but it has a slope of 2, and it's going to be valid between 0 and 5. So I'm going to go to where my graph says x is 5 right there, and I'm going to graph the line in this little region. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, until I land on the other line, put a bubble there, and I'm literally just connecting those. That's a line, should be straight. And because this is underlined for this function at x of 5, I bubble that in. And then finally I have a line at 3, so at 5 though, x of 5, go up here, put an open hole. This is not underlined, so I'm just going to go off to the right because it's a right arrow there. And that's how that would look. So make sure your line's a little bit straighter than mine there, but that's how you do it. Okay, the next section is and you definitely have something like this on the quiz, so make sure you understand it. You're evaluating the function, the piecewise function, but now not algebraically. You're going to go to where the graph is -1, and you're going to go up and you're going to see, oh, y is a 1. Go to where the graph is a 2, go up. This is not actually your y, it's actually up here at 4 because the circle is filled in. Then go to where x is 5, go up, y is at 3. So that's what you're doing in that section. Extrema are just going to be max or min values, and they're actually going to be either absolute or relative. So you're kind of looking for either one of those. So what I have here is I come up here, I have a relative max, kind of traveling along, I have a relative min, and then when I go up here, I have an absolute max. And then all of these y's are less than this y, so these are kind of just all constant. So I have to designate those three. So this is going to be -1, 1, and that is going to be a relative max. Then I have 0, 0, which is a relative min. And then I have 2, 4, which is going to be your absolute max. So that's from the last part of the unit. And then intervals of increase and decrease. So let's review this because it's been a while. So do you see that negative infinity, all of these x's, my y's are getting bigger. So all of these x's I'm increasing until I get to that -1. So it's going to be negative infinity to -1. But then if you notice, it goes down, so I don't want to use this. This is my decreasing. But then it starts to increase again between 0 and 2. So from 0 to 2, it also increases again. It only decreases in this one little interval here between -1 and 0. And then it's going to be constant from 2 to infinity. So I'll say 2 to infinity here. So constant, just a horizontal line. Okay? And the x-intercepts are going to be -2, 0. So this graph crosses right here and right here. So you have to be careful. And the y-intercept is actually at 0, 0 as well. And can you write the equation of this piecewise? I feel confident you can do that. So that goes over some from each section. Finish the review, check your answers. I will be here in the morning if you need to come in for any help. And go back and watch some of the old videos I've sent as well. That might be helpful. Go over the old homework, etc. And I will see you guys tomorrow.